So today we are doing notes on writing equations in slope-intercept form. So slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So sometimes we'll be given the question, write an equation of a line in slope-intercept form. I'm just going to write I for slope-intercept, SI for slope-intercept form, with slope equal to -2 and y-intercept 5. Okay, so we're just going to plug those in for m and b, and that's going to give us y equals -2x plus 5, and it's really just that simple. Okay, next one, let's say they give us slope of 3/4 and y-intercept or point 0, -3. So we know that 0, -3 is the y-intercept because for y-intercepts, x equals 0. So for this, we're going to write our m and our b, and we've got y equals 3/4 x, and then I can just make it -3. So let's write an equation given a graph. So I'm going to draw two graphs. These are part of the problem, not your answer. So the first one, it helps if you have graphing paper for these notes, but I know not all of us have access to that. So okay, and we got a line going through these. So this is the point 0, -5. And this is the point 3, -1. Now, normally I would encourage you to count rise over run to find your slope. So here's our example. But in this case, since my graph drawing is terrible, let's practice slope formula. So remember, slope formula is y2 minus y1 over x2 minus x1. So we can label our x1 and y1, x2 and y2, because for slope-intercept form, I need both of these guys, right? We are given the y-intercept, so this is our y-axis. It crosses at -5, or you can look at the coordinate and say, okay, x is 0, so that's my y-intercept. So we know that this is -5, but we don't know our slope. So we're going to solve for our slope. So y2 is -1 minus y1, which is -5, over x2, which is 3, minus 0, which is x1. So if we make that minus negative a plus, we got -1 plus 5 over 3. So -1 plus 5 is 4. So our slope is 4/3. And that's going to go in that spot. So we've got y equals 4/3 x minus 5. So that's how you write it from a graph. Okay, flipping the page. We've got another example of a graph. So this is example B. So let's say we've got the first point's at 0, 1. So hopefully that clicked in your brain that this is the y-intercept. And then the next point is at 4, negative 1. So if they don't give us the y-intercept, we're going to talk about that later, but we have to solve for it some way. And so today we're going to learn how to solve for the y-intercept using just the slope-intercept form. And then on our next set of notes for point slope, we're going to use a different formula to find our y-intercept. But this one's the same steps as the other one, so we need to find our slope because we have our b, but we need our m. So we've got m equals y2 minus y1 over x2 minus x1. So let's label our stuff. We've got x1, y1, x2, y2. It doesn't matter which ones you label, the ones and the twos. So we've got m equals y2 is negative 1 minus 1 because y1 is positive 1. Then we've got x2 is 4 minus x1, which is 0. So negative 1 minus 1 is negative 2. That's over positive 4. Then you can simplify this fraction. The top and the bottom are both divisible by 2. And we get negative 1/2 as our m. And our b was 1. So our equation is y equals negative 1/2 x plus 1. Okay. So there's a couple more examples normally that we do in person, but I can do those in class. And now let's write an equation in slope-intercept form given a table. So our next example, we're writing in slope-intercept with a table. All right, so our first table we're going to have negative 2 to positive 2. And then we've got negative 3, negative 1, 1, 3, 5. Okay, and so if you guys remember from our linear functions lesson, we talked about finding the change in y and the change in x. So remember slope, another way of writing slope is change in y over change in x. And a shorter version of that is triangle y over triangle x. The triangles are like in Greek symbols called delta, but they mean the change in, okay? So I like to create a little delta range on each side of my chart. And then that's where we put our pluses and minuses. So to get from negative 3 to positive 1, we would add 2. This is delta y. And negative 1 to positive 1 plus 2. 1 to 3 plus 2. 3 to 5 plus 2. So they're the same all the way down. So on the left side, they should also be the same. Negative 2 to negative 1 is plus 1. Plus 1. Plus 1. Plus 1. All right, so we know it's for sure linear. Always double check that. So my change in y over change in x is going to be 2 over 1, or we can just write that as 2. And we also need to find our b. So what's our y-intercept here? Now remember, our b happens when x equals 0. So this point, 0, 1, is our y-intercept. So b equals 1. So we've got our m, and we've got our b. So now we can write the equation y equals 2x plus 1. Done. All right, so we'll do one more of those, and then we'll talk about whenever they don't give us the y-intercept. Okay, so let's do a sideways chart this time. Horizontal, I guess, would be a better word for that. So on our x's, we've got -5, -2, 0, 3, 5. And then on the bottom for our y's, we've got -16, -7, -1, 6. Wait, what does that say? Let me zoom in. Hold on. Old people eyes. Can't tell if that's an 8. Okay. 8 and then 14. So we need to find our change in y over change in x. So we can add our delta x and delta y parts of our chart. So to get from -3 to -2, I have a +3. -2 to 0, +2. Okay, now we notice that they're different. So we need to actually double check that this is a linear function. Then we've got 0 to 3 is +3. 3 to 5 is +2. On the bottom, from -16 to -7, we would add 9. -7 to -1, we would add 6. -1 to 8 is +9. And 8 to 14 is +6. So it looks like we have two fractions here. So we either have 9 over 3, don't forget y goes on top, or I want to know if this is equal to 6 over 2. If they're not equal, then I stop and say it's not linear, because you can't write an equation for a line in slope-intercept form if it's not linear. So 9 over 3 actually equals 3, and 6 over 2 equals 3, so we're good. And our slope is 3. Okay, now we need to find our y-intercept. That's when x equals 0. So our b is -1. And we can write our equation y equals 3x minus 1. Okay, so let's talk about whenever we don't have 0 on the table. So 0 for x, obviously. So I'm going to flip the page. Never mind, new page. Okay, so new chart. So we've got a chart without b in it. Okay, so let's do a vertical chart this time. We've got 1 through 5 on the left side. And 11, 15, 19, 23, 27. So this isn't the only way to do this. Okay, don't forget that. There's actually like a pretty simple way if you're good at patterns to figure out when x is 0, what is y. But we want to use our formulas just so we can get better at using our formulas. So the first step is still to find our slope. So we do our delta y and our delta x table. So to get from 11 to 15, we add 4, all the way down, they're the same. And on the left, it's just add 1 all the way down. So our slope is delta y over delta x, which is 4 over 1, which we can just write as 4. So now we need to put it into slope-intercept form, but we're missing our b. So we've got y equals 4x plus b. Now, something that we haven't talked about that's a tool that we have is we have tons of x's and y's. So we can pick any point on this table, any point, and make it our x and y so that we can solve for b. And it's just so we can solve for b. Those aren't going to be in the actual slope-intercept form equation. So let's pick 319. That one's kind of random. So this is going to be my x. This is going to be my y. So I have 19 equals 4 times 3 plus b. So now I need to solve for b. So I've got 19 equals 12 plus b. Subtract 12 from both sides, and we get 7 equals b. So our equation ends up with our m being 4, our b being 7, and we get y equals 4x plus 7. Okay. The way to do it with a pattern is, as you can see, like going down, it's plus 4 each time and plus 1 each time. So if I went minus 1 and went up the chart 1 and got 0, then I would do minus 4 on this side and I would get 7. So that way it ends up being easier most of the time, but sometimes it's not, and you have to know this strategy just in case. Okay, so make sure you've written down all of these notes and get ready to do your homework.